The climbing wall is a popular event at the Springfield Fair. The wall is 100 meters high. Bart can climb at a rate of 8 meters per minute, but other participants climb at different speeds. Let x equal the rate at which he climbs in meters per minute, and let y how many minutes it takes to reach the top. So let's put in his rate, 8 meters per minute. So if it takes him 100 meters to reach the top, I'm going to go down here and write 100 divided by 8. I think I have to put an equal sign in. Nope, 12.5. So it takes him 12.5 minutes to reach the top. So we've got that plotted where the x-axis equals the rate and the y-axis is the amount that it takes, the length or the number of minutes it takes to climb to the top. Let's think of some other times. If a person could climb at a rate of 10 meters per minute, it would take them 10 minutes to reach the top. If a person climbed at a rate of 5 meters per minute, it would take them 20 minutes to reach the top. What if they were faster? What if a person was able to climb at 20 meters per minute? Well, then it would only take them 5 meters to meet the top, to reach the top. What if a person could climb at a rate of 50 meters per minute? Well, then it would only take them 2 minutes to reach the top. What if they were a little bit slower? What if they could only climb at a rate of 2 meters per minute? Why, then it would take them 50 meters to reach the top. Do you kind of see what's going on with this graph here? If we were to think about what sort of an equation we could write for this graph, notice that to figure out y, we have to take 100 divided by x, because we're seeing if it's 100 meters tall, and this is how many meters we can climb in a minute, then this would be how many minutes it would take. We just divide. So we could write an equation, y equals 100 divided by x. And notice that goes right through the points that I graphed. Let's kind of think about some other points. Go back to my little chart here. What if it took, if a person climbed at a rate of 100 meters per minute? Well, how long would it take to reach the top? Only 1. What if it was, they climbed at a rate of 150 meters per minute? 150, 100 divided by 150 would be, was it 2/3? 2 divided by 3. What about if it only took, what if someone climbed at a rate of 1 meter per minute? It would take them 100 minutes to reach the top. Now let's think about what if we kept going? What if we kept making the pace even slower? What if we went at 0.5? It would take 200 minutes. Can't even see that. I'd have to kind of scroll down there. There it is, right there. Now let's think about what happens. Can we ever reach a place where it takes no time at all, like 0 minutes to climb? They would have to climb infinitely fast for it to take 0 minutes. There's no way for it to take 0 minutes for them to climb to the top. You couldn't go fast enough to have 0. You'd have to be like the Flash or something. And even then it didn't take 0, just a very, very short amount of time. Also, is it possible if we went at a rate of 0, what would happen? If it went at a rate of 0, how long would it take to get to the top? Well, it would take an infinite amount of time. That's undefined. I don't even know if I can enter that. Probably won't even allow me to do that. See, it doesn't like it if I write that. So what we have here is a rational function. A rational function is a function that is a ratio of 2 polynomial functions. These are both, of course, very simple. A constant function, a constant, and an x to the first. But by definition, that's what a rational function is. it's going to have variables in the denominator. So it's going to have places where we get undefined numbers. I can't put 0 in for x, or y is undefined. If x gets really, really, really big, y gets really, really close to 0. So these are characteristics of rational functions. They have asymptotes. An asymptote here at the y-axis and another asymptote at the x-axis. They have undefined values. Something we notice that as x gets really, really big, y tends to level off, or as x gets really, really close to a certain number, in this case 0, y gets really, really big. So this is just an example of a rational function, and we're going to start exploring rational functions in this unit. Before I end this video, I do want to point out one thing. There is no x-intercept and no y-intercept on this function. We've talked about y, but let's just reiterate it again. There's no x-intercept because y can't equal 0. In order for y to equal 0, the numerator would have to equal 0. In order for y to equal 0, I'd have to come up with some value of x that would make y 0, and that's impossible. There's also no y-intercept because if x is 0, y is undefined. So in order for a fraction to have an x-intercept, the numerator has to be 0. In order for it to have a y-intercept, we have to have a value for x. I have to have a legitimate way to make x equal 0. In this case, neither one is true.